Hello, intro to stats class. Today we are going to start probability model. That's section 7.2 here, and that's section 7.2, and we're going to start with probability model. The probability model, it talks about how many possible outcomes are there. It talks about two basic things: list all possible outcomes, and also possible probability for each possible outcome. So it first talks about how many possible outcomes are there, and then it talks about what are the chances for each and every outcome. And when you collect all the possible outcomes, that becomes a sample space. So means if you toss a coin, so if you do that, you have to check what are the different outcomes. So probability model for there, it's going to be heads and tail. That's the list of all possible outcomes, and probability for each outcome, that's 0.5, and here 0.5. You have that, and the sample space in this case will be sample space in that case is going to be head and tail. So that's a very basic example. The probability model discusses all the possible outcomes and the probability for each and every outcome, and the sample space is the collection of all the possible outcomes. Let's move to the next part. So in your book they talked about the probability of model of marital status, and what they did, they chose women from 25 to 29 year old, and then they checked whether they are their marital status. So they have different categories here: never married, married, widowed, or divorced. So they got the probabilities for each and every one. And when they talked about the probabilities here, what happened, like never married, and here the three categories they belong, three possible outcomes: never married, widowed, and divorced. So in these three cases, you can consider a single bigger group that's going to be not married. If someone is not married, means they never married, either never married, or you can say they are widowed or they're divorcee. So you can combine this one, and this one, these three categories together, and when you add the probability, that's going to be 0.548. The numbers are a little bit different from your original textbook, so it's fine. And if you know never married, not married, so you can also there is another way of finding how to find not married probability when person 1 minus probability of married. This is the way you always find. If you're finding not happening something of any event, so you find 1 minus probability of happening that event. So it's always figured out like that. So here we know that this is already given here, that 0.452, that will come here. So we get the probability of not married is 1 minus probability of married, you subtract it, and finally you get 0.548, and that is actually true. So you see, either you add the categories here, all three subcategories, and add the probability, you get the same number, or you simply, if you have the probability of that event happening, like probability of being married, that you have it, so you can always not married one you can find by 1 minus, and you should be getting same result. All right, so we can basically say, so that's a probability, and when you convert that in percent, so 45.2% are married and 54.8% are not married. So let's move to the next part. Next is talking about the basic rules of probability. You have the basic rules of probability here. So basically it has 4 basic rules according to your book. The first rule is it has the of any event is a number between 0 to 1. All right, second one, all possible outcomes together must have a probability 1. Then third one, the probability that an event does not occur is -1. The probability of that event does occur. And the last one, if two events have no outcomes in common, the probability that one or the other occurs is the sum of their individual probabilities. All right. So basically, what does it mean? The very first one, that you have to keep in mind that probability that's always between 0 and 1. It cannot be less than 0, cannot be more than 1. So 0 means, if you talk about 0 means it's impossible. And when you talk about the probability 1, so it means it's sure that it's going to, it's certain that the event is going to be, so its event is sure to occur. All right. So and any other category is probability is between that. And other rule says all possible outcomes together, the second one, together must have probability 1. So means if you have different outcomes of any probability, and suppose there are 3 outcomes, so if 3 outcomes A and B and C for any certain event, so when you add the probabilities of all those events, your sum should be, so you have to add them, it is going to be 1. All right, it's exactly 1, not it's not going to be little bit more or less. Third one is probability that an event does not occur is 1 minus the probability that the event does occur. So it's just like you did the marital status. If you have to ever find the does not occur one, always find, so in general you write it probability of A complement, means of any event not happening, is 1 minus probability of that event happening. So you can always, there are two events which are complementary, and they're the possible outcomes for the certain event. So one thing that is does not occur, this is does not occur, that is 1 minus, that is probability where it occurs. All right, now we have another last one. If two events have no outcomes in common, then the probability that one or the other occurs is sum of their individual probabilities. So what you can do, you can just add all the probabilities of certain subgroups of any outcome. Like here, suppose there are, if one event occurs 40% of all trials, and the different event occurs 25% of the all trial, but then we also know they never occur together, they're not occurring together, they're just separated. Then 65% of the trials, when you add this 40% and 25% here, that is going to be 65%. We can say that probability of A plus probability of B is probability of C, and we get the probability of both events occurring. All right, so like here, event A, suppose you get 2 heads, like for an example, and B is getting 3 heads. If you get 2 heads and 3 heads in a coin tossing, these two events have no outcomes in common. Like you can, if you're tossing a coin, you cannot get means if you're tossing 2 coins here, or here 3 heads, all right, so you don't get the both events A and B, they're not going to be together, so they're kind of mutually disjoint. So you can add their probability if they have nothing in common. So then if all outcomes in a sample space are equally likely, the probability that event A occurs can be found using the formula. There is another Another, yes, one more, I just skipped it. So it is, if you have to find the probability of certain event, and but keep in mind that each outcome is equally likely, means they have the same chance to occur. There is no priority that one event will occur more and other will less. If they have the same chances of occurring, then you have another formula that probability of A is number of outcomes of corresponding to event A and over total number of outcomes in sample space. Alright, so let's see what does it mean. So we can talk about that by probability model rolling two dice. So imagine we have two fair six-sided dice, and it's shown in the next page. And if the dice are fair, and what we do, we uh, roll them and we will check how many possibilities are there. So we see there are 36 possibilities, and we say the sum has to be 1, and each outcome must have the probability 1 over 36 because they're going to be equally likely. So let's see what is it. So we can see that the green, we have two die, and here we have um, a red one and the green one. So we have sorted out different combinations for green and red here. So two dice, so when I count, so that goes 1 2 that goes 1 2 3 4 5 6, and the same way 6, and when I count 1 2 3 4 5 6, 6 6 is 36, so total 36 possible outcomes when we rolling two dice, one red and one green. And suppose if we want to find our probability, the even A roll a 5, we want a 5. Alright, so if we know all events are equally likely, so we can use the previous formula where probability of A is roll a 5. That is basically you have to look for how many events here getting 5. So if I look carefully, I see this one is 5, this one is 5, this one is 5, and this one is 5. So how many cases total we have? And you can see there are the 4 different cases. So we have the first one, second, third, and fourth. And what's the probability of each and every case? Is just 1 out of 36. They're occurring just once out of 36. So 1 out of 36 here, and 1 out of 36, 1 out of 36 plus 1 out of 36, and when you solve you get 0.111. But if we are finding the complementary, the event or the probability of the complement when the sum is not 5, as I told you, when you know it's sub 5 and you have to find not 5, it's 1 minus when it is 5. So 1 minus probability sum is 5, so 1 minus 4 over 36. So it's better to take fraction, not the rounded value. It's right thing to take fraction here, and you solve it, you get 0.889. So that's all for today's lesson, and please let me know if you have any question. Till then, stay safe and thank you.